In the last lesson, we discussed the use of the questionnaire survey. We talked about the advantages and challenges of using a questionnaire. We also talked about some good practices of designing a good survey. Once you have conducted your research, the next step is to analyze your data. In this lesson, I will talk about the use of statistics to analyze your data. There are two basic types of statistics that you need to know. First is the descriptive statistics. And the second one is the inferential statistics. Now, the use of the descriptive statistics is to help you describe and summarize your data. Inferential statistics, on the other hand, is to help you predict something about your population from the data. In this video, I will talk about some of the most common measures of descriptive statistics. Now, suppose you are interested to study how tall people are. And you have collected data from these 11 individuals from a population of 100 people. So, for example, individual A has a height of 60 inches. Individual B has a height of 57 inches, C 62 inches, and so on and so forth. So what are some of the ways that we can use to describe this data? One way to describe the data is to use the method of mode. The mode is simply the most frequently occurred scores in the data. So let's calculate the mode here. 60 inches, we have how many people? We have only one. 57, how many people have 57 inches? Only one. 62, we have 1, 2, 3. 3 people. 65, we have 1. 70, we have also 1. 58, we have 1. 63, we have 2. And finally, 69, we have only 1. So from this distribution, what do you think the mode is? Obviously, the mode is 62, because this is the most frequently occurring scores in this whole distribution. The next method to describe your data is to use the method of median, which means the middle score in a distribution that has been ranked. Now, to do the mean, to find out the median, the first thing that you need to do is to rank them up from the smallest to the biggest number. So, for example, what is the smallest number here? 57, followed by 58. What else? 58, we have 60. And following that, we have 62. 62, 62. We have 263. We have 69. And finally, we have 70. Now, what is the middle score in this whole distribution? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We are missing one more number, 65 here. 69, and 70. Okay, let's count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. What is the middle score in these 11 scores? It will be here. 1, 2, 3, 4, 5. Here, this is the middle score. 1, 2, 3, 4, 5. So 62, this score is the median of this distribution. So for our data here, we can say that the median would be 62. Okay? Let me just give you another example. What if we have another individual called L? Individual L, let's put it down here. Oh, individual L, and the height is 71 inches. Okay, then we will have another score called 71. Now in this case, the scores would be 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What will be the median? It will be 2, 62 and 63. Because these two scores will be the median. Okay? Because there will be 1, 2, 3, 4, 5 and 1, 2, 3, 4, 5. So these two will be the middle scores. So in such a case, you will have to take the average, which would be 62 plus 63 divided by 2. This will give you 62.5 inches. Just now we talked about two methods to describe the data. If you remember, we talked about the mode and then we talked about the median. The third method that we can use to describe our data is to use the mean, or some people call it the average. Now the mean is the most common method to describe data. How do we calculate the mean? We need to add all the sum, all the scores in a distribution and divide it by the number of the data. So for this distribution, what is the mean that we have here? You can find it to be 60 plus 57 plus 62 plus 65 plus 70 plus 58 plus 62 plus 63 plus 63 plus 62 and finally plus 69. Alright? This will be 691. And then how many of these scores do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there will be 11. So the mean, symbolized by this, would be 691 divided by 11, which is 62.8 inches. So the average or the mean of this data would be 62.8 inches. We talk about the use of mode and median and mean to describe the data. Now the last method that we talk about would be the standard deviation. The standard deviation is also a very common method used to describe your data. What does the standard deviation mean? The standard deviation basically means how far your scores is from the mean. Okay, let's look at this table and we will calculate the standard deviation. Right, so here will be the distance of the score from the mean. Right, so remember the mean that we calculated just now was 62.8. So in this case, we will be, for A, for individual A, it will be 60 minus 62.8. here will be 57 minus 62.8. This one will be 62 minus 62.8, so on and so forth. Okay, I have calculated it in my hand, so I'll write down the answer here. So the first one will be minus 2.8, second one will be minus 5.8, minus 0.8, 2.2, 7.2, minus 4.8, minus 0.8, next one 0.2, 0.2, minus 0.8, and finally the last one will be 6.2. Okay? Now this score will tell you how far each of these score is from the mean. Alright? Now to calculate the standard deviation, we will need to multiply this to the power of 2. Square them. Right. So minus 2.8 times minus 2.8 would be 7.84, 33.64, 0.64, 4.84, 51.84, and let me just fill up the rest of the data. Okay. The formula for the standard deviation is this. The square root of the total of the spread to the power of 2 divided by the total number of data minus 1. So in this case, the total will be this, everything here, total up. 7.84 plus 33.64 plus 0.64 plus 4.84, 51.84, add them up. This will be 161.64. So it will be 161.64 divided by how many data do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 10 minus 11 minus 1, sorry. Okay, this would be square root of 161.64 divided by 10. You will have 4.02. Now this is the standard deviation. Okay, just now we calculated the standard deviation of 11 scores from 11 people. Okay, now what is the use of a standard deviation? Okay, if you look at this graph, you will see the usefulness of standard deviation. Now this is the mean, right? This is one standard deviation away from the mean, and then another one also will be one standard deviation below the mean. So this is one standard deviation above the mean, and this one is one standard deviation below the mean. Now, studies have found out that between these, here you will have 68.3 between plus and minus 1 standard deviation. Okay? And if you have 2 standard deviation above the mean and 2 standard deviation below the mean, you can actually say that there are 95.4% of scores falling between these. Alright? And finally, 3 standard deviation above and 3 standard deviation below the mean, you basically capture almost all the scores between this whole distribution. Now, based on this information, what can we tell about the height of people that we talked about just now? Now, if you remember, the mean was 62.8 inches. And if you remember, the standard deviation was 4.02. So let's simplify it to be about 4. Right. Now, using this information, we can say that 68.3% of heights will be between 62.8 plus minus 4. What does it mean? That will be between 58.8 and 66.8. Alright? So 63% of heights will be between 58.8 inches and 66.8 inches. Okay? Let me just erase this. We can also say 95.4% of heights will be 62.8 plus minus 8. Remember, 95.4 between plus and minus 2 standard deviation from the mean. So we can say 62.8, the mean, plus and minus 2 standard deviation, which is 4 times 2, 8. So this one will be between 54.8 and 70.8. Get it? And finally, we can also say that 99.7% of heights will be 62.8 plus minus, now what do you think the standard deviation here will be? Okay, remember this is 3, right? So, we will have 4 times 3, right? Would be 62.8 plus minus 12. That would be between 50.8 and 74.8.